So we're going to go over Z-scores and normal distribution. Okay. Now, normal distribution, it's very important when we're working on our Z-scores that we're working with normally distributed data. That means that's data that roughly has this bell curve shape around what's considered the mean. Okay. Now, the mean is some value, and we'll make up a value after. They usually denote it by calling it x bar. That's our mean. Okay. And then they talk about deviations from the mean, and we talked about how to find a deviation. So once we find a standard deviation, what does that tell us about our data? Well, let's say talk about one standard deviation from the mean. So I've drawn this, okay? So our mean is here. This would be plus 1 standard deviation, and this would be considered subtract 1 standard deviation from the mean. And according to this, when it's normally distributed, what this means is any information that is within 1 deviation, plus or minus 1 deviation from the mean, when it's normally distributed, that's roughly 68% of all of the data falls in this region, okay? Then we talk about 2 deviations. Oops, wrong button. Same idea. This is considered plus 2 standard deviations, and this is minus 2 standard deviations. So before, when we talked about 1 standard deviation, that was all the info in here. Now when we talk about 2 standard deviations, we're talking about all the info, including the 1, and pushed to the side too. And according to what we've learned in statistics, okay, this is, all of that contains 95% of the data. Okay, so 95% of data falls between 2 standard deviations from the mean. And finally, 3 standard deviations is really all we go to, okay, for statistical relevance. Plus 3 standard deviations and minus 3 standard deviations. Turns out that 99.7 is the actual value. I should really look that up. But approximately 99% of all data, yeah, it's 0.7. 99.7% of all data falls within 3 standard deviations. Okay, that's wonderful, but what does that mean for us? Okay, how do we help make sense of this? Let's group this info and paste it to another page. Okay, so we're talking about all the data here. Okay, well, let's say, let's paste that. There we go. Oh, what happened there? Let's try that again. Oh, I didn't copy it, sorry. Delete that. Sorry. Okay, so here we go. We got our standard deviations. What does this mean? Okay, well, let's say we're talking about next year, 2014 NHL scoring. So we pool all the players at the end of the year, and it turns out the mean, X bar, the mean scoring is, in that shortened year, because I think this year, what, Crosby in 2013 was short. Okay, let's just say the average player scores 30 goals. Okay? And we do all of our calculations, and we discover that a standard deviation, usually known, all right, our standard deviation happens to be 10 goals. Okay, so we'll say 10 goals is our standard deviation. Okay, so the average player, or the average of goals scored of all the NHL is 30 goals. Now, what we do here is we kind of use this information to get a hold of all of our data here. So let's say that 1 standard deviation plus, well, in that case, we're adding 10 goals to this. So this means 40 goals, and we subtract 10 this way, because that's 1 standard deviation, 20 goals. Well, it turns out, remember we talked about 68% of the data, right? It turns out that 68% of all the NHL players scored between 20 and 40 goals. That's pretty logical. That makes sense. You're going to say majority of players score between that many goals. Then we broaden our statistics a little better so that we can make an even better estimation about the NHL. Okay, so let's say we go up another 10. So we add 10 from the previous one. That puts us at 50 goals and 10 goals. Well, according to that, what color did we do that one? Red. Before. Between 2 standard deviations, okay, between 10 and 50 goals, well, that's 95% of all players. That's pretty logical too. That 95% of all the players in the NHL get over 10 goals, but less than 50. Okay. And finally, our last one here we'll talk about is 60 goals and 0 goals, right? So 60 and 0 goals, what that means, according to all of our data, is that 99.7% of all the NHL players got between 0, which makes sense, 0, and 60 goals. Now, there is a very small percentage who would get over this, and now it doesn't logically make sense to be less than 0 goals, right? But maybe we could say a guy, his only career game scores on his own net, right? So those are from very rare, and essentially it's really rare to find people outside of that. To get over 60 goals is a lot of goals, and to get under 0 is a really rare occurrence, but it's really rare. Look at that. The percentage is 0.03% of NHL players will be outside of this range. So this is almost the range of the entire NHL. That's a pretty logical estimate for what we've done here. Okay, now let's talk about a Z-score now. There's many ways we can talk about a Z-score in this case. And we'll use it with these goals here. So let's say we got a player, and first of all, let's talk about Z-scores. Z-score. How to calculate how many deviations we are from the mean. What we do is we take our data. X stands for our data. Okay, so the information, how many goals there are. X bar stands for the mean. And our theta here is our standard deviation. I'm going to call it SD. Okay, so we take the data, we subtract our mean, and we divide by our standard deviation to find a Z-score standard deviation value. Then we use that Z-score to find out what percentage of players fall to the left of that. And we're going to include it in here. Okay, so let's say I make the NHL, or we find a guy, and he happens to score 45 goals this season. Okay, so in that case, our data is 45. We know our mean was already 30, and our standard deviation was 10. We had all that information. So let's find out what the Z-score for this guy is going to be. Where's he going to fall? Well, that we take 45, we subtract the 30, and divide by 10. That's going to give us 15 divided by 10, which is 1.5. So in other words, what this is, does that make sense so far? Yeah. This guy who scored 45 goals was 1.5 standard deviations above the mean. It was positive 1.5. So, and that makes sense. He's roughly there, right? That would be 1.5 standard deviations above the mean. 45 goals. Makes perfect sense. Okay? But let's say we want to know what percentage of players scored fewer goals than him. Okay, well, we're going to have to try to calculate this, and this is where our Z-score table comes in handy. We have to look up 1.5 on a Z-score table. Okay, so here we go. We have our Z-score table. Sorry, there it is. Now, this Z-score table is a little different. If you notice here, this is our 1.5, which is perfect. Okay, but this Z-score table is only one-sided. See, it only has positive values here. Okay, so because it only has positive values, what it expects you to already know that the mean, that 50% of the data is to the left of it and 50% is to the right. Okay, and all this does is calculate the percentage of data from the mean. Okay, what the heck does that mean? Okay, think of it like this. Here's our mean. We know that 50% is to the left, which means 50% must be to the right. So this table is just going to tell us how far, in a positive fashion, what percentage is to the right of the 50. So all of our values for this Z-score table, yours might be very accurate. If it has both ends, you won't have to do this. We have to add 0.5 to that. And we should always make logical sense of what we're doing. Okay? So when I look up on this Z-score table, I discovered at 1.5, we have 0.49322. So in other words, what that's saying is from here to 1.5 is 0.4, what did they say, 0.45? 4332. So 0.4332. That's how much data falls in between there. Okay? Okay, so what they're saying is that's there, but to the left of it is 0.5, to the left of the mean. So we're going to actually have to add these two values together. Okay? Now, you might not always have to do this. So this value gives us 0.4332, right? But that's from the mean. So we have to add 0.5 because we know 50% is to the left of that. So when we add this, we end up with 93.32. In other words, roughly 93%. So approximately 93% of the players in the NHL scored less than him. Okay, and let's try to logically make sense of that. Let's make sure that works. Okay, well, we know that this is 68. Okay, so half of it would be 32, and we know to the left is 0.5. So 0.5 plus 0.32 is already 82%. And that makes sense. We're probably another 10% in here. So logically, this makes sense as a percentage. Okay, I know that's a little confusing, that idea there. Your Z-score table will give you this exact value when you look it up. Okay, and what if they said what percentage of players scored above that, above these 45? Okay, well, in that case, we're going to have to take 1 and subtract our 0.9332. Okay, and that's going to give us 1 subtract 0.9332, 0.668. 0.0668, which is approximately, almost 7%, right? That makes sense. Well, 7% of the NHL scores more than 45 goals. Again, pretty logical for what we're doing here, okay? So that's kind of how we work with Z-scores, how we find them, and how we try to make sense of them with standard deviation and what we're doing here.